Well, good evening. It's another Alta3 Monday. You guys ready to get started on actually, in this particular case, some OVS knowledge? I'm going to show you how to network Open VSwitch. Ready?
Sounds good. Take
Yeah.
it to the next level here.
Yep. So, have y'all seen this lab before? I think Zach, you and I actually taught this. Jason, Chad, you guys never taught this, right?
Never taught it, but I did run it once upon a time.
So you ran the labs. Okay. Well, there was something about this lab that was always bothering me. It really, I just felt it needed something. So anyhow, let's just run down through. I have already SSH'd into a machine called Alpha, as you can see. I'm not going to do the update of the Open VSwitch. You know what? Maybe I better. I honestly, goodness, I don't know if it is installed. It's not. So while we're doing that, that's fine. I did the IP list and everything's fine there. But what was really bothering me is once this playbook runs, this Open VS Kettle, I don't care about showing you this help thing. It's this add bridge called Donut Planes. It bothered me to no end. So I'll go ahead and run that for you. So this will, well, before we do it, let's get out of the basement here. And if I just do an IP list, nothing fancy there, right? So let's add the switch. And we're going to add this switch called Donut Planes. Emphasis on Donut Planes. But bothered me because I'm not really of that ilk. And I run the IPL, and it's like I see this Donut Planes. Now, words cannot describe how clear networking is to me. I honestly, I'm like oneness with that. But let's get you guys out of the picture right now so that we can just sort of focus on this. And I want you to, seriously, I want you to help me out now. So this Donut Planes thing, this is Super Mario World. Am I right?
That's the start world, I believe we're looking at.
Oh,
yep.
Okay.
Yep.
That's taking me way back.
Right about there, I think it's Yoshi's house.
Yoshi, yeah.
There's Yoshi's Island. There we go. Yep.
And I figured out that this is Donut Planes because it's a donut. This little lake makes a donut. Did you know that? And then Twin Bridges, and then Forest of Illusion, and then Chocolate Island. Right?
25 years, and I never knew that was a donut.
Yeah, well, trust me, you understand that I'm analytical, and I just can't stand it. And something as simple as Open VSwitch that is unbelievably crazy, and then this something incredibly complex as Super Mario World, and I just wasn't getting it. So okay, so Super Mario Land. Not land. See, that's humor right there. Okay, that's as good as it gets. So the question I have then is,
that's pretty good.
If I go, no, it's not. So if I go from here to there, can I like go over to there to Chocolate Island or Twin Bridges, or do I have to go to there? I just want to know, is this a router or a switch?
I think you got to go to there.
You do. So then this would be a trunk then. And so these different LANs are trunked together is what we're saying. All right. Which means that if I'd want to get to here, I'd have to go through a sequence like this, which is a reason, by the way, that when you're interconnecting Ethernet switches, you never do this. That is really bad design. If you're going to do that, you would actually network them like this. And you would never think that you could learn all this networking from Super Mario Brothers. But in this particular Super Mario, but if you go like this or you go like that, it's always through Donut Planes if that's what would be your core. So that tells me then that this is an Ethernet trunk, as the case may be. And we're cascading these switches, which is really bad design. But okay, so actually that makes it clear to me what's going on then. So the only thing left was, why did we call it Donut Planes? And then it occurred to me, each one of these was an island, a little place that you guys stopped on So I think this was actually Brian wrote this particular lab, and I guess he was thinking that these would be interfaces in a switch. So if we take donut planes and we go from that, I'm thinking the original author of this was thinking of this as donut planes, and that each one of these are the drop-off points. So you get the analogy there. That was probably the most meaningful thing for me in all of this, like, so that's where that came from. Nevertheless, then, I want to actually send traffic into donut planes and send it over like this. Before we do, let's do a little bit of analysis on the IP address. So let's bring you guys in here on this. I want to see you on this one. So question is, that /24 right there, wouldn't that put the dividing line right here?
Yes.
Right? Yeah.
Yep.
So this part of the address then would be known as the network address. And what do you notice about these two?
They're the same.
Therefore, they're on the same subnet, which means you don't need a router to go from one to the other. And what's going to actually have to understand that is this part of the IP address, which is the host. One of the challenges in teaching this is students will look at an IP address as a name. They will view this as a name. They see a single number. And what they don't see is the entire trip. If we would go back and say, regrettably, this would not work, because if these were routers in between there, and this would be a certain subnet, these are subnets, and that would be something like this, to a really strong networker, the networker would look at the IP address and immediately see a path. They wouldn't just see the destination. They would see the path the whole way through if this were routing between all of these. Now, in switching, it's a straight shot from MAC address to MAC address, and that's what we have right here. So an Open VSwitch is the perfect thing for this. So right now we've just created that, and we see we have it because right there it says donut planes. Crystal clear so far? Yep. So the next thing is to create some VETHs, plug them into some namespaces that we have to create, and ultimately just exec into this namespace and ping the other guy. And this presentation's done. It's straightforward as that. So without any further ado, let's just go ahead and run the script. I could run the script in one whack, but that's too boring. So let's just copy this and let's paste that in there. Now, notice that is going to create a network namespace, in this case called Peach and Bowser. There's a bit of Linux stuff going on there. What's that ampersand greater than doing?
That's sending your standard out to dev null.
Yeah, we do this to protect the students. Why? You know? If you send all of the complaints to dev null, what do you wind up with?
You don't run into anything. I did have a student point out. So the reason is if you try to add a net namespace that already exists, it'll bark.
It'll bark at you.
Net namespace already exists. But I have students, that get confused if they get the barking. I also have students that say, well, I need to see that barking in order to
yeah. But
know what I'm supposed to see.
But if I did this, like Zach suggested, you've wrecked what you're trying to teach just went away, because that's not even an error. That didn't break a thing. That just says cannot create. It says file exists. To an expert, that'd be shrug of the shoulders, move on. So that is part of our craft, is actually do this. Now I'll zoom out here and we'll just grab all of that, right? So this is going to create the VETHs. Now, what's interesting on this particular case, let's hide you guys for a minute so we can see this. And if we run that, what you wound up with is two VETHs just laying there. So you'll notice that I see a pair of VETHs right here, and I don't want that. I want one end of this VETH plugged into that guy, and the other end of the VETH, I don't want to see it because I want it to plug it into this namespace that I created. So these VETHs will actually disappear as soon as we plug them in. So let's go ahead and do that. Now, what's interesting, let's clear this. Now let's do IPL. And you'll notice that the component count went down. Better did. I feel like it didn't. Net to Peach. I'm going to keep charging anyhow. I'm going to add the assignments, and then if there is an issue, I'll come back and fix it in a moment. But this is a proven script, so I'm not going to second guess it. So we're going to add the IP address. The thing is, I just plugged Peach to net, so that's this. I just plugged this VETH into the Peach namespace. So that means in order to apply an IP address, I have to go into here, or we have to go into there. And this is classic stuff. You see this in Docker. You see it all over the place. The hardest things for the students on this one is sudo IP net namespace exec Peach. That is the target. So there's two commands right here. How do you guys explain this that it doesn't instantly confuse the students?
Hey, Stu, let me point out, I think you added, I think you skipped moving the one end of the VETH into the namespaces. So if you look at the commands, the two commands you issued, didn't you just create the VETHs up there? Sudo IP link add Bowser to net type with
no, I created the network namespace. I actually created the VETHs.
Right.
And this
but then you didn't move the V. I don't think you did that.
Oh, did I run this again?
Yes. I don't think you
okay.
Good catch, Zach.
Thanks, Zach.
you moved
Oh, yeah.
So that moves the VETHs into the namespaces. Now, if
now the count's down. That's what I should have seen. Yep. Okay. Yeah, I got tangled on the presentation. All right. So, but okay, let's get back to this then. There's a bit of craft involved in teaching this, because this is basically saying the following command, but this is the actual command, I want to execute in this namespace. I find the only way to ever explain this with clarity is to draw on the screen. I don't know how you would explain it in a blog. I don't know how you would, unless you actually mark. This is one of the cases where I just think you have to mark up code to make it clear. So right now, if I were to exec into Peach, for instance, so if let's just take a visit into there and bash, right? So now I have a bash command. If I do an IP A for address, there's no address in there. But while I'm in there, I could now issue this command, couldn't I? But I'm not really teaching that. I want to get out of that. And I'm back here into Alpha, and I can combine that. This means go into the namespace called Peach and then run that command. And I'm just going to cut and paste both of these. Now, if I bash into there and do an IPA, you'll notice that IP address is indeed now assigned. Right here, guys. Right there. I'm looking at it. And there's the other end of that VETH. So let's clear this. And
so you just statically assign two IP addresses to.
That's all I did. Yep. Yeah. So what happened was these two addresses just got assigned to these interfaces. But the other end of the VETH, because this is not a bridge internal, these are VETHs, and I wanted to take a minute and explain why this is probably not a good idea, is actually to IP exec, so that's going to bring the Peach interface up. You'll notice that if we went, you know what, let's just go down into there, because there's actually some elements of what I did there that I didn't like. I want to show you all right, alpha, right?
Yeah, SSH alpha.
Let's SSH into, let's bash into Peach. Now watch this. I'm going to do an IP TAC CL. That just adds color. How those colors coming through, by the way? It's looking okay, right? At least that red down is not looking good. I showed you the command before like this, and that loses all training impact. The color makes a big difference. We should probably incorporate more of that when we do this stuff. So that being said, let's run these final commands, which will bring the interfaces up. And it'll also plug them into the Ethernet switch. Now let's SSH into Peach. All right, sorry, bash into Peach. Now we do an IP TAC CA. We want to see the address, and now we see they're up. And if I ping, whatever the IP address is, I'm in Peach, right? So I actually want to ping 164.2.3. I want to ping that guy right there. Yeah, okay. Troubleshooting time.
Something's down.
Yeah, has to be. My guess is it's down. I don't see that this ever got plugged into the switch. Where did this VETH ever get?
Well, that's in root, right? So
no, this is a VETH. So I mean, this plug the VETH. Okay. If we just continue to add, if we just continue to read the lab,
RTFM, right?
Yeah, RTFM. Read the manual, right?
Yeah. What's
no
that?
No one ever tells me what the F stands for. No one will tell me. So, all right, let's exit out of here, and we don't want to.
No, I think you have that script run. I think 10
Yeah.
and 11. What's
We want to run these.
The other side into.
Yeah, well, that just did. That just
OVS.
plugged. Yeah, that just plugged into it. So test connectivity. This is going to be exec into Peach and ping the other guy. So if we run that, the results, and yep, it's working. So we actually made this work. This is a layer 2 connection that we just saw. Now, some of the issues about using a VETH. It exists actually as a Linux kernel thing, which means you have Linux kernel capabilities to it. The downside of it is the interface between Open VSwitch to the VETH right here is not as clean as if the people who wrote the code for Open VSwitch, they said, well, wait a minute. If we wrote an interface with this end dangling, we could make this interface far more efficient in the kernel. In fact, we could make this run in user space, as opposed to there is a kernel requirement in a VETH to go from there to that side. It's a bit of a speed bump, guys, when you do this. If you scrap the VETH with what's called a bridge internal, then this speed bump is eliminated. Obviously not that end. Nevertheless, when we ran iPerf speeds between this, even on our network, we were seeing about 28 gigabits per second. And I believe that probably could be improved with some KVM modifications that we're looking at as well. So there you have it, the creation of a layer 2 connection. Probably what I like most about this is just how visible it is. If you watch Sam's video the last time, he actually had a namespace basically on the other side that these came in, and he was doing a routing function in there. That is not visible. The rules to get traffic to hop from this interface to that interface and continue actually require IP routing, and that's far more complex and a completely different lesson. All right, that's it, guys. I think that brings it to an end. Let me bring you back here. Questions on that? How do you think you could apply it? You know, that sort of thing. Yeah, it's right down, Chad. Do we need to show networking fundamentals like this more often in what we do?
Yeah, totally. This is something that needs to be part of the bigger picture for anybody who's studying networking.
I mean, I don't know how long my demo was. We're 20 minutes in. We should probably finish the video like soon, but you realize there, other than plugging stuff in with Linux commands, there's almost no difference between this and an actual physical switch. Yeah, and
I do these demos for, I guess, either when people have questions about what NFV is in general. I do these. I mean, they're applicable to container talks if you're just trying to explain how namespaces, specifically network namespaces, are handled and why it might be clever to abstract them. I like this lab a lot. I think it's a good one.
Yeah, it's incredibly visual. This is the first lab you should work and make it super clear and you understand it. Then you have to go into routing. All right, guys, that's it. Let's wrap it up. See you next time. Bye, everyone.